Absolutely, Doug.
Okay.
Well, good morning. Come on, one more time. Good morning. There we go. Well, I'm Mike Pappas, W9CN, and today we're going to talk about vehicle power systems. Before we start, I kind of need to give you guys a little background so you can understand how we got to this point. A long time ago on a planet far, far and away, different lifetime, another galaxy, I started off with Edge of Space Sciences, which are a bunch of ballooniacs. And when I started doing EOSS, it was probably flight 110 or 115. And in those days, my chase vehicle was a 2002 Cadillac, which was kind of insane. I broke 3 sets of motor mounts with it. My Cadillac dealer would always laugh at the number of birds and things that he'd be taking out of the radiator after a chase. But in those days, it was pretty simple. We had a laptop, an FT 8900 was a single radio in the truck, and away we went. And then over the years, things changed. And all of a sudden, you start getting a whole pile of gear in the truck, right? And so I went from a Cadillac to a Ford Ranger. That wasn't big enough. And then I went to an Explorer, and that wasn't big enough. And then I finally ended up with a 2001 Excursion, and that's kind of big enough. But as part of this, there's a whole pile of gear in here. And the electrical loads in the vehicle have quadrupled, right? And now we've got so much stuff in trucks and radios and all kinds of other things that it starts to impact the electrical system. And as part of this, I took a pretty good sized deep dive into what happens in vehicle electrical systems and how do we run technical loads in a vehicle, right? Technical loads, computers, radios, things like our EOSS bricks. So this is an Intel-based industrial PC running Linux that does all that tracking stuff that you saw on that first slide. But all this stuff eats power, and lots of it. How much? Enough so that we got to put a fan on it to keep it cool. And, now we have computers in the front seat of stuff and radios and all kinds of things going on in here. And how far did the craziness go? Well, the craziness went so far that we carry a SLR 5700 DMR repeater that's linked into RMHAM via 5G LTE. All that stuff eats more and more and more power. And of course, then there are these little incidents where our payload is draped across 3-phase 7200 volt distribution, and the local power company is out going to get it off the lines for us. None the worse for wear, by the way. But as part of that, we run into a situation where we've got all of our cars lined up on the side of the road, and they're all idling with all this technical gear running in them for maybe hours. And that creates a whole set of problems with vehicle electrical systems. So the ABCs of vehicle power systems. A vehicle power system consists of 3 parts, typically. A, alternator, B, battery, C, control system. Okay, that's where we get the ABC. Notice how I kind of folded that in. It's the best joke you're getting today. Okay? It was. In a much simpler time, this was kind of the de rigueur for vehicle power systems. And there's some very interesting things that have carried over. A long time ago, we had generators in cars, right? And to this day, you'll still see references to generators, right? Now, we haven't put generators in vehicles since we kind of went over to 12-volt power systems in cars, which was like the late 50s. And they consist of several things. So even though this says it's a generator, it's really an alternator, okay? So we've got an alternator. We turn the alternator on, there's a battery, and off you go. It's pretty simple stuff. Well, it's not that way anymore. And that's where we start getting into some interesting stuff. So let's talk about alternators. Alternators, they're a three-phase device, okay? Remember Tesla, three-phase AC? Well, guess what? It's in your car, right? So we have a three-phase stator. That's the coils on the outside of the alternator. This is an alternator, GM 200 amp alternator. Then there's a rotor field coil. That's the thing that spins around in this thing. Then we have rectifiers, 8 of them, and a voltage regulator. Here's what one of those looks like taken apart. By the way, those things are heavy. So if we look at this picture, this is a fully assembled unit. This is it all blown apart. Stator coils, rotor, field coil, rectifiers. That's a cap that's hopefully to scrape off some of the noise so you can actually get AM in the vehicle, AM radio in the vehicle. Pulleys, bearings, case. You notice the case here has got lots of holes in it. That should give you a clue about something that we're going to talk about, which is heat. So there are lies, more lies, and alternator specifications. Okay, so I'm a member of the Society of Automotive Engineers, and when I started looking into alternators and what's the whole specs? How does this thing get running, making any sense? So I dug around and I pulled the SAE specifications. Alternator rated output is measured at 6,000 RPM shaft on the alternator. Now, why is this interesting? Because 6,000 RPM relates to between 2,000 and 3,000 RPM of crank speed, crank RPM. At idle, which is 1,500 RPM typically, the alternator is at half of its rated output. So if you have a 150 amp alternator at idle, it's going to be about 75 amps, maybe less. So just as a rule of thumb, the alternator is running at about twice the speed, RPM speed, that the crankshaft is. It's just kind of a rule of thumb. And as such, when you look at your car specs and you say, well, I got a 150 amp alternator. Well, that's great, but at idle, it's going to be at 75. And where that starts to jam you up is when you start throwing all kinds of technical loads in the vehicle that are going to run while you're parked at the side of the road on a mission for 3 hours. The other issue here is that the SAE specs measure it at 72 degrees. Now, I can tell you right now that under hood, in my excursion in the summertime, at idle, with the AC running and everything else, it's well over 140 degrees. Now, what do we know about electronics when we get them really hot? Okay? They don't perform as well. And that is something that's got to be factored into what you look at in terms of available power in the vehicle at idle. Let's talk about vulnerabilities in alternators. The absolute number one killer of alternators is heat. Okay? It absolutely destroys alternators. Now, in the 70s, alternator rectifiers weren't anywhere near as good as they are today, but they're still not all that happy running at 150 degrees ambient air temperature. They've gotten better. The other issue is that the more load that we put on the alternator, what happens? We end up generating more heat, which of course doesn't make our situation any better. And that's why when we look at alternators like this one, you'll see that the case has got a zillion holes in it. And the reason for that is to improve airflow and get rid of the heat that kills alternators. The trend recently, from a manufacturing standpoint, is to put the smallest alternators they can shoehorn into a vehicle and still keep it running. Right? They are not building these things for guys and gals like us who are going to stuff a whole bunch of extra electrical loads in the vehicle. They are designed to get the smallest alternator and the smallest battery they can in that vehicle. And that means that when we start throwing extra loads on the vehicle, all of this stuff takes a beating. Now, rectifiers, Tatatel is an OEM manufacturer that supplies virtually all the U.S. domestic manufacturers with regulators and alternator rectifier packs. This is a Ford 6G rectifier pack, and you can see here these posts are the diodes in that rectifier pack. So there are 8 of them, 1, 2, 3, 4, 5, 6, 7, 8. This one's rated at 200 amps. It's using avalanche diodes. And you can see again, the case here is wide open. Again, to try to get as much airflow past those rectifiers to keep them cool as possible, because Tatatel knows that heat kills rectifiers. And they have an aftermarket division that sells these. So if you want to rebuild your own alternator or come up with your own custom alternator, you can call Tatatel and order that stuff up. Stator coils. Those are the coils that are on the outside of the alternator. The typical failure point for those is vibration, and they don't like high temperatures. Here's a picture of a stator coil. And you can see what that looks like. The Ford ones actually have another terminal here instead of just 3, but that was the best picture I could find on the web. Regulators. Again, our favorite bugaboo here is heat, electrical system fault, and wear dirt on the brushes and slip rings. So the regulator's job is to provide the field coil, which is the thing that spins here in your alternator, with voltage. And that voltage is regulated so that the stator coils produce the correct amount of voltage. And this is a Ford 6G regulator. This is where the brushes are. They're retracted at this point. When you install this, you pull a slide out and the brushes drop onto the slip rings. This is the one we use in our 250 amp alternator in the truck. And the interesting thing about this is the set point here is 14.8 volts. So we're running our alternator, usually alternator set points are 14.4, but we're using AGM batteries in the truck, and they want 0.4 volts additional voltage to properly charge them. The other interesting thing here is that the field drive current, how much energy do we put in the field coil, is, wait for it, 8.3 amps. So the field coil at full output is going to dissipate 122 watts just in the field coil. There's some other interesting things here. Load response control rate. So one of the things you have to do when you throw a bunch of loads on an alternator is you can't immediately snap its output up to full output, for example. You have to ramp into it. And the reason for it is so that you don't destroy the serpentine belt stuff on the front of the vehicle. Now, where this gets to be tricky, and we're going to talk about this, is modern vehicles now tend to have systems that turn the alternators on and off. And they do that, we'll talk about it later. I'm not going to run down that rabbit hole right now. This is typically the chip that gets used in regulators. And so you can look this up. It's a L9409. And those are typically what's hiding inside of that regulator package. And it's got load response controls, self-start functions, all kinds of really interesting stuff. You can pull the data sheet up and learn more about regulating alternators than you ever wanted to know. But it's interesting to read this stuff. Why? Because it's going to affect how the vehicle behaves when we throw a whole bunch of loads on it. Rotor. Wear dirt on slip rings, bearings, and they have significant rotational mass. Now this thing at highway cruise speeds, or somewhere between 2,000 and 3,000 RPM on your tack when you're going down the road, this bad boy is running at twice that. So this thing's running at 6,000 RPM. If you take your truck or vehicle up to redline, this thing can easily eclipse 18,000 RPM. Okay, that's a lot. You know, I started doing the math on this and I was like, wow, no wonder we eat bearings in these things. Mix in, for us, out on dirt roads in the middle of nowhere with all kinds of dirt in the air, and you start to see where you start to develop problems. The other thing that I want to point out is there's a whole slug of rotational mass here, which I kind of walked around and said, here, give this thing a twist and feel how much rotational mass is there, right? Now, why is this important? Well, because if I'm slinging this thing around at 12,000 RPM, right, and I don't have a load on the alternator, so this thing's freewheeling, right, and the transmission goes from redline back down to 3,000 RPM, I got a pile of rotational mass here that's going nowhere except back into the serpentine belt and all the stuff that's on the front of the vehicle. Okay, and that's a problem. And that's what one of those things looks like. It's not a great picture. The interesting part here is you'll see there are drill marks on the, for balance. You got to spin this thing. Imagine if that thing wasn't balanced and it's running 6 to 12 or 18,000 RPM, right? That thing would be, it'd be coming off the front of your car. We talked about rotational mass. New alternators have clutches, which is another area of complexity and failure. It's referred to as an overrunning alternator pulley, or OAP. Its whole design is to reduce the shocks on the front drive belt system. And this is caused by, remember we talked about rotational mass? It's caused by the high rotational force of the alternator going to war with the crankshaft. Now, it's not going to hurt the crankshaft, but everything else that's on that serpentine belt path takes a big beating. And we'll tell you why that happens in a minute here, but if you take a look at your alternator, and if your alternator has a plastic cap on the front of it, you have an OAP. Now, most modern cars do. And that's what's inside of an OAP. So there's all kinds of kind of clockwork precision stuff stuffed in there. And that's what it looks like assembled with the plastic cap on it. Now, let's talk about batteries here. We're going to come back around to the whole system in a minute. So there'll be a test on alternators. So if you haven't taken notes, we're going to ask questions. So a battery is a chemical storage system. All right. In automobiles, it's referred to as an SLI battery, which stands for starting, lighting, and ignition. It doesn't say anything about radios. Okay? On most vehicles, it's a lead acid design. The design's been around forever. You know, The only changes have been that in the old ones, if you're old enough to remember, you used to be able to take the caps off and put distilled water in there to make up for the losses in the system. Now we don't do that. I have some feelings about that, but I think it basically revolved around the fact that people never did it. Or if they filled them up, they didn't put distilled water in them. So they just made it so you can't do it at all. Here are some numbers that you kind of want to remember, and these are important. 1, a fully charged lead acid battery is at 12.5 volts, and that's after you bulk charge it, disconnect it from the charger, and wait 24 hours for the surface charge to bleed off it. A 50% discharged lead acid battery is at 11.5 volts. That's half capacity. And it's fully discharged at 10.5 volts. Now, AGM battery voltages are higher by about 0.4 volts. Batteries, lead acid batteries are rated in cold cranking amps and cranking amps. Yes, Tristan.
Yes, on the previous slide, you're talking about normal. So the previous slide, you're talking about normal vehicle batteries, and those are not deep cycle, right? So if you're at the 50% level at, I think you said 11.5 volts, that's actually close to ruining the battery, right?
Well, so let's talk about battery cycles, right? So this all gets back to what happens in modern vehicles. So, correct, the more we cycle a battery, the further we cycle it down, right? Going to 50% back up, right? The less life the battery is going to have, right? If you want maximum lifespan out of a lead acid battery, you don't want to cycle it to half, and you certainly don't want to go all the way to won't start my car anymore, all right? Because that just absolutely slays the life expectancy, okay? Now, you certainly can put a deep cycle battery into your vehicle, right? There are some compromises there, and we'll talk about some of those issues when we get a little bit down the road. But correct, the more we cycle the battery, the more we discharge it. I would not, when I test batteries, I have a West Mountain radio battery analyzer with the 1,000-watt amplifier on it. So I can discharge batteries really quickly. But when we do a battery test, we stop at 11.5. And when we do that test, I've just taken another life cycle right off the top of that battery. Right? So we don't want to test batteries until we really got to test batteries. And 10.5 volts is an absolute killer. So that was a great question. Cold cranking amps. This is probably the most important number that you're going to see in Colorado. Okay? Discharge load in amperes that a new, fully charged battery can deliver at 0 degrees F for 30 seconds while maintaining a voltage of 1.2 volts a cell. Now, 1.2 volts a cell, I have to put my glasses on because the type here is really small, is 7.2 volts in a 12-volt battery. Okay? And that's really low. Cranking amps, this is kind of like under the heading of I got a 150 amp alternator, but really at idle it's only 75. Cranking amps is kind of misleading in Colorado because this is measured at 32 degrees. It was 16 degrees this morning when I left the house. And so CCA is probably your best bet. Now, where CCA gets to be really important, diesel trucks, big engines, high compression ratio, those are things that really stress the battery's ability to deliver current. Reserve capacity, the number of minutes a new fully charged battery at 80 degrees Fahrenheit. Okay, notice these temperature numbers all kind of change, and that's because the chemistry works better. And again, batteries are chemical devices, right? Really cold temperatures, less capacity. Really high temperatures, less capacity, right? All of these things are really designed to work. The chemistry works best at where humans work best, right? Outside of that, everything kind of changes. And this is the reserve capacity. How much current can you suck out of the battery for how long before it hits 10.5 volts? Again, we don't want to do that because it beats the life cycle to death on the battery. Lifespan. Battery lifespan pretty much is based on how much abuse you give the battery. I feel I'm doing really good if I get 3 years out of one in ham radio application. I've never hit 5. Now my wife's car will do 5, but she doesn't have a radio in it. Again, less if you beat it to death. High temperatures are not good for batteries, which is great because where do we put batteries? Engine compartments, okay? Engine compartment can hit 160 degrees Fahrenheit in the summertime with the AC running, stop by the side of the road, sitting there for 2 hours while I'm waiting for a balloon to show up. Cold temps reduce the available cranking current. So, of course, as part of this, I wanted to take a look at how much cranking current it takes to turn over my Ford Excursion V10 Triton engine. So on a 20-degree morning, I got out there with my current probe, my fluke current probe, and a pair of fluke meters, and I decided to crank the engine and see how much current it took. Anybody want to guess? Come on. How about 486 amps? Okay, at a battery voltage of 10.49 volts. So it took 5 kilowatts, a little more than 5,000 watts to crank that engine on a 20-degree day. That's a lot of horsepower. It was 6.6 horsepower to crank the engine. And your battery's got to turn all that over and have enough voltage in it so all the electronics in the vehicle can start the ECM, fire the injectors, spin up the fuel pump, make all that stuff work, right? This battery's right at the ragged edge. At 10 volts, it'll turn over, but none of the electronics will come up, which means you're not going anywhere. Now, once the engine spun up, the other interesting part was how much current did the alternator shove back into the battery? 84 amps. Okay? That's a lot of current. Now, where we get into a jam is modern vehicles use advanced power system management techniques. And these include cycling the alternator on or off. And that's why we talked about rotational mass and putting clutches on the front of alternators. Okay, so if the engine control modules turn the alternator off, and this thing's spinning at 6,000 or 12,000 RPM, and we go up to red line and the transmission shifts down, there's no load on this thing. All that rotational mass is spinning there. That's a lot, right? The clutch allows that rotational mass to keep going without destroying the serpentine belt and all the stuff on the front of your car. That's why it's there. Typically, they like to cycle the alternator on and off and run it down until the battery gets to half capacity. Okay? And then they turn the alternator back on. So some of those clutches are soft loading, right? If you turn the alternator back on like that, and you happen to be at effectively 12,000 RPM, that serpentine belt is not going to enjoy it. So the OAPs work both ways. They disengage for an overrun, and then they soft bring you back online, so it's not pinging the serpentine belt the other way around. This is complex, right? Some of the Ford stuff now has a data bus that talks to the alternator and tells the alternator how much voltage to deliver, and they've got a Hall effect sensor on the output of the alternator measuring how much current's being delivered to it, and another one on the battery showing how much load's coming off the battery. And they play all these games to make this work. But doing this discharge, as Tristan pointed out, to 11.5 volts is a 50% cycle on your battery. And that's not particularly good for long battery life. It kills batteries, okay? The cynic in me says they got that system designed to just get it outside of the warranty on the vehicle and then stab you for a $200 battery, okay? They would never do that. The reason they do all of this craziness is because they're trying to improve gas mileage. And I don't quite understand the thought process of letting you discharge the battery to 50% capacity and then turning the alternator back on to charge it back up, right? I mean, those losses, at least to my way of thinking, are greater than if we just let the alternator run and maintain the battery. But bigger minds than mine are working on this. So the ECM looks at the bus voltage and current being delivered by the alternator and the current in and out of the battery. It makes some decisions to turn on and off the alternator or decrease or increase its output. Sometimes it just turns the alternator off and waits until you hit, wait for it, 11.5 volts. The EPA gives automobile manufacturers a 0.5 mile per gallon CAFE bump for doing this, even though it doesn't improve gas mileage in the EPA MPG test cycle. It does sell a lot of batteries.
So we got rid of the lead and gas.
Yeah, absolutely. Yeah, no, it's crazy. And if you look at your battery on the negative terminal and you see something that looks like this, that's the state of charge sensor for the battery, right? Sometimes you'll see them here. Sometimes they'll be on the negative lead. GM occasionally on some of its cars puts on the negative lead. It's a circular Hall sensor. A close-up of one of the GM ones that goes onto the negative terminal looks like this, with a GM part number on it. All this does is make it more interesting for us to figure out a way to get radios to work in vehicles. And on some GMC trucks, you might be able to defeat that whole on-off alternator deal by unplugging the battery current sensor. Now, when you do that, it's going to toss a CEL, check engine light. But they'll typically go out in a couple of weeks and you'll be back to running a normal electrical system. But I mean, it's crazy that we've got to resort to this stuff to get this stuff to work. So now you guys have and gals have an overview of some of the challenges in modern vehicles in terms of how do we get radios installed? How do we get radios installed that actually work? And, we have to start thinking about what's the meaning of life in radios. Currently, Motorola, and I just picked on them because it was convenient, recommends that the radio be fed directly from the positive terminal of the battery. And then the negative line is tied to a chassis. And this is one of their install bulletins for an XTL radio. And you can see the DC power cable is here, and the red lead goes all the way to the battery. There's a fuse here. You'll want to make sure that fuse is there, guys and gals. fusing, it's good. And then they're showing that the negative lead's connected to chassis. Again, note the fuse on the positive side. Fusing, it's good. Let's see a show of hands. Who's blown fuses? Okay, just about everybody here. On the negative tied to chassis, I try to put the negative lead as close to the battery as possible. There's a reason for it. Okay, batteries, when they're in good shape, effectively act as capacitors and scrape off a whole bunch of electrical system noise. So you really kind of want to get your radio cranked up right across the battery, because any place else that you put it potentially has a bunch of other junk on it, especially things like chassis where they tie everything. Why? Because that way they don't have to buy ground wires. So I tend to like to get them near the battery. And remember, you've got to put it on the far side of that current sensor. You can't put it in front of the current sensor, or the computer in the vehicle is going to go, wait, the battery isn't at the charge state that I thought it was, because you're drawing current off the battery that the system isn't metering. That bolt where they put that negative lead onto the chassis, that's a good place to hook radio grounds up to.
I was always taught to put a fuse on the negative as well, for the reason that a lot of high current things like rear window defrosters use the chassis ground, and occasionally as those things get dirty and rusty, it brings the return path through your radio, and you don't want that. So what are your thoughts on fusing the negative?
Well, we used to fuse the negatives all the time, and for just that reason. The other thing that would happen is you'd get a braid between the block, engine block, and the chassis, right? And that, when I grew up in the Midwest, it was home of salt, right? How did I know when it was time to buy a new vehicle? When I got in, looked down, and could see the road, right? I mean, you know, I had a car that was so rusty, couldn't see its own shadow, all right? Yeah, and so what would happen is they'd have a braid that ran between the block and the chassis, or somewhere near the battery, and the salt would eat that braid up, right? And then when you cranked over that 5,000 watts, that 5,000 watts was going to try to go on the ground line from your radio back to the battery. And there was no good that came from any of that. And Motorola, for a number of, actually General Motors had a technical service bulletin that said, connect the radios right across the battery and put fuses on both sides. And that was the TSP from GM. I haven't burned up a radio negative lead since I left Milwaukee. And the best view of Milwaukee I ever had was in my rear view mirror as I waved goodbye. So I tend, well, look, if in doubt, right? But remember, there's no free lunch. And fuses have a finite amount of electrical resistance, because if they didn't, they wouldn't be a fuse, right? And the other problem you run into is we've cooked fuses, blade fuses, that have gotten a little bit of a snoot full of water in them, right?
So you're talking blade fuses.
Yeah.
And like typically with a Motorola radio, they give you a large cartridge fuse. The old Ericsson GEs had that cartridge fuse that's basically half the size of your little finger, and 40 amp, 60 amp sizes. I found those to be pretty reliable, but you're right, blade fuses.
Well, so what
Not
would
so
happen
good.
is you build up some moisture in the blade fuse, right? Which would cause, wait for it, oxidization. And where I lost most of my blade fuses was in my Whelen Edge 9000 light bar, and on the strobe power supply. And that was a 20 amp fuse. And one day I came out and the back side of the Edge wasn't running. So of course you got to disassemble that thing, and sure enough, it burned a hole right through the fuse holder and right through the fuse. And so now what I do with blade fuses that are going to be exposed to the outside world is I use some non-hygroscopic lubricant, right? You don't want to use anything that's going to collect moisture. So you got to make sure that whatever you're going to use in there is non-hygroscopic. It's not going to collect moisture. And I get the blades gooped up with that and stick them in there to try to keep the moisture out of them. But I've cooked 2 rounds of blade fuses before I did that in my light bar. So again, you got to be careful about managing points of failure, and you got to pick the hill you want to die on. Okay? Well, because the last thing you want to do is be out on some mission or doing a support for a race or something, right? And you're out in Timbuktu and your radio checks out because your blade fuse ate itself. It's really good input.
On it, and you can't see it here, but I pulled up on eBay Motorola fuse. They're available for like $12 in sizes 4 or more. It's a cylindrical. You put the cartridge fuse in. There's a rubber seal. It crimps down on the end. Heat shrink. Water is not going to get in this thing. You could put up to a 60 amp fuse in it, which is more than any radio you're going to deal with. And I've had very good luck with these under the hood. They don't take on water, but you're right. You don't want to get moisture and crud in there. There are some sealed. They're maybe not submersible, but they're certainly very water resistant.
Well, and again, I
out
think
there, and for $12,
you can't miss.
yeah.
I just tend to use what Motorola gives you in the wiring harnesses.
Motorola gives you, well, they give you what they give you.
They give you what they give you.
That's how they're going to do you.
Things that you should never use in a vehicle. Cigarette lighter sockets. Okay? There is absolutely no good that comes from using a cigarette lighter. Okay? They're absolutely designed to be cheap. You know, you got to look at the automotive industry and you got to go, you know, if they can save $1 a vehicle, and there's somebody like Ford who's making 250,000 F-150s and you can save $1 a vehicle, it's $250,000 that you just put into your shareholders' back pocket. And those folks are squeezing every nickel they can out of those vehicles to make a profit. The grounds on those might be 15 or 20 feet long of very, very, very thin wire. And that's not a good place to run a radio out of. I'm not too thrilled about running a PC out of one of those. At the end of any OEM wiring harness, you know, if you've got an upfitter breakout, you want to take whatever that upfitter switched output is, you want to run it through a relay. You don't want to run anything that's, and then build a technical load out from there. You don't want to use the upfitter switches for anything other than turning the power on and off. All right, so now we're going to get into battery boosters. Tristan, go ahead.
Right, so the topic of places not to attach your radios. What is your opinion on using the cabin compartment fuse blocks? It is really hard on a modern vehicle to get cabling through the firewall. They cram things in there so tight, and I'm really good at fishing cables in places like that, but my modern car I gave up, and I tapped into a switched fuse under the driver footwell.
Is it working?
It works, but I'm also not running crazy amounts of power here. It's I have 2 mobiles, 40 watts.
So we're going to hop into battery boosters here, and I'll tell you how much amperage your 40-watt radios are going to run. So you're probably okay because they're under 10 amps. And if it, you know, how do you know you got a wiring problem? Transmit audio's got alternator whine on it. Okay, you know, the radio dims all of its lights when you hit transmit. Not good. right? So what we're going to do here is we're going to take a 5-minute break, and then we're going to hop into battery boosters, okay? So let's all rendezvous back here at 25 after the hour, and we'll pick it right back up. Perfect. So welcome back from our quick break there. We're going to hop into a discussion of battery boosters. I'm not a particular fan of battery boosting. Every time somebody in EOSS has tried one of those, the first thing I hear is they got 20 over noise, and it kind of comes and goes. Boosters are usually PWM devices, and they vary with loads. And so, of course, in the spirit of doing fun testing, I pulled a setup together and cranked around with a booster and looked at it with my Rhodian Shores spectrum analyzer. The other issue that nobody talks about with boosting batteries is they're 90% efficient. So that means if you got a 100-watt load, when you run it through a battery booster, you now have a 110-watt load. Which, if you've already got a problem with your electrical system not being able to deliver enough power when you're at idle, parked by the side of the road for an hour or so, you've just made it 10% worse. These are some of the things that folks don't consider. This is a block diagram of the MFJ battery booster. And this is pretty typical for these kind of devices. There's some switching transistors. They actually have an input filter to try to keep the switching transients from escaping back out the input side of this thing. Then they've got an output filter, again, to try to keep the RFI it's generating from downstream devices. There's a boost control, a voltage control, some other stuff here. This is the schematic diagram for this device, which is nice that they actually gave you a schematic diagram. They're using a SG2525 magic regulator PWM controller to make all this work. You can pull the spec sheet up. It's real interesting. It runs up to 500 kilohertz. So start thinking about that for a minute. Let's look at where our harmonics fall here in terms of what amateur radio is trying to get done, right? And they've got an output choke and a bunch of filtering here to try to clean all that stuff up, but there's no free lunch here. This is the spec sheet on the chip they're using. It's made by ST. Regulated pulse width modulators. You can pull this data sheet off the ST website. It's very interesting reading. I'm not going to go into a deep dive on the technology. This is the N8 XJK Super Booster. This is the original schematic diagram from '04. But kind of a similar thing. You got a couple of FETs that are working in push-pull, right? So one FET's closed, the other one's open, these reverse. That causes a giant magnetic field here, the width of which is varied based upon how much voltage and current you're drawing on the other side of this. Lots of filtering caps here, lots of filtering caps on the input side. Again, the big issue is the PWM is going to change based on how much load you've got, which means that you can be in situations where with a particular set of loads, you are generating all kinds of RFI right in the middle of something you really need to be listening to. And it only occurs when those planets just line up. And again, we've had a member at EOSS that put one into quote solve his sitting by the side of the road insufficient vehicle power system problem, and then couldn't hear anything, but only at certain times. They're using an LM 3524 regulating pulse width modulator made by TI. It's a nice piece. It's got its own set of, it's different than the ST Micro one in a couple of different ways. You can look all that stuff up. It's always interesting reading. There's no free lunch with using a booster. It cannot create power out of thin air. In fact, it creates 10% less power than you put into it. The lower the battery voltage, the more current the booster will pull from the battery. And if you look at a discharge curve on a lead acid battery, as you get down to 11.5 volts, this thing is drawing more current out of something that's already at half its capacity. Ohm's law always wins. Always. If we take just a number, let's take 110 watts. Let's take 100 watt of load from a radio, pick it, right? By the time we run it through the booster, we've got 110 watt load. Why? Because the booster is only 90% efficient. So you're at 110 watts. Well, at 12 volts DC, it's 8.8 amps. At 11.5 volts, it's 9.56. And at 10.5 volts, which is effectively a completely discharged battery, it's at 10.47 amps. So as you get into, I don't have enough battery, I'm shoveling more, I don't have enough battery, out of, I don't have enough battery to try to make that work. And that's not good. This is from the MFJ manual on noise reduction. To reduce noise to a minimum, ground the case of the MFG to the automotive chassis with as short of a wire or grounding braid as possible. So if you've got one of these bad boys, you don't want to run an 18-inch piece of wire between it and the ground. Why? Because 18 inches is a quarter wave of 2 meters. Okay? So that's kind of self-defeating because all that RFI is now running into an antenna, right? And if you're going to use a battery booster, what you really want to do is mount it someplace where you can drill some holes. We're going to go back to Tristan and drilling holes in a second here, where you can drill some holes and put some sheet metal screws right into the chassis so that there's no possibility that whatever you've got this tagged into is going to be radiating something into a band that you want to look at. Okay? I mean, that's and I tried that when I did my setup. And you know what? It works perfectly. If you put an 18-inch piece of wire, you can watch the amount of noise come up in the 2 meter band by about another 3 or 4 or 5 dB. Yeah, wow. Tristan's like, holy cow, that's a lot. So Tristan, let's go back to, I forgot to ask you about the let's mow holes and things question you had.
Yeah, I think we were talking before the break about how difficult it is in modern cars to actually find places to get through the firewall because they cram the engine compartment so full of equipment and everything is in curvy shapes that tries to optimize for space. Back when I had my old car, it was very easy to find a spot where I could go straight through. There were lots of wiring harnesses already going back and forth between the footwell and the engine compartment. And I could just follow one of those. But now it seems like goes around 5 different corners before it actually penetrates through the firewall. So drilling into that obviously gets a lot riskier. You're willing to have to tear more stuff apart to reach it.
Well, and so when we were mowing a hole through the firewall on the Ford, what we found was there was an inside firewall and an outside firewall, and there was about a 1/4 inch between the two of them for reasons I couldn't quite understand. Because we popped the first hole through, and I was like, well, we went through, and then there was like no daylight coming through it. And I guess the good news was we didn't stumble upon anything that was running between those two pieces of metal that had a lot of current on it. But the short answer is it's very difficult to work on modern vehicles and find ways to get through the firewalls. When I had my O2 Cadillac, they had the battery under the back seat, which made putting the radios in the trunk really easy because there wasn't a firewall between the trunk and the back seat. So you could just snake the wiring underneath it. But it's a real challenge. And, the tendency is to try to not take your car apart and not mow holes in it. And it's going to be a set of compromises. And I think, you finding a switched line in the car that you could tag off from is a really solid solution to finding a way to get around it. Again, I know the radios you're using and I know how much current they draw because we did a whole bunch of testing on it for this. And, you're under 10 amps, it's probably a good solution. And as long as you got a very solid ground and nobody's complaining about the fact that you've got some sort of alternator whine, is really good. So I'd say you made the best set of compromises that you can, knowing that it's simply impossible to do that kind of work on a modern car.
Yeah, I did connect the ground straight to the chassis, basically by pulling back some of the carpet and finding a good spot to screw that in. So that definitely helps.
Well, one of the other problems you run into is the paint with clear coat is non-conductive. So if you're gonna if you're gonna make your own ground spot, or if you pull a nut off something and there's paint under there, you're gonna need to get that. You're gonna either have to use an aggressive star washer between the surface of the vehicle and the lug, and then you're gonna have to torque that down until it bites through that paint. But I ran into that problem on my '02 Cadillac. The paint was so thick and so good that it formed an insulator. At one point, we ended up using a Dremel tool to get that cleaned off to the point where there was real metal there, because even a star washer wasn't reliable. And in radio installs, you're only as good as your ground.
Ford Explorer, and it was a lot of work to try to get through the firewall. And what we ended up doing was just go through the floorboard and go into a loom and take it up to the battery, because you've got wires and stuff under the vehicle and some things anywhere or anyway. And that was, it was just almost impossible that we could find a place to get through without going through the floorboard.
Well, that's a really great suggestion, Mark, because I actually had not thought about it. And I've spent enough time under the Excursion that I know there's a bunch of that stuff down there. And, the Excursion was so big. And look, it was a 2001 that I bought 10 years ago. So, us going after it with a bunch of 3/4-inch hole saws and banging around with it wasn't like I just dropped $90,000 on a vehicle and I'm taking the interior out and I'm cutting it apart. I think I paid $5,000 for that truck. Actually, the gear inside the truck is worth more than the truck. Now, one of the interesting things here is getting back to boosters and RFI. I want to talk about RFI suppression and the meaning of life and ferrites. And they say clamp on ferrite beads can be used on the input and output power leads to further reduce the noise. This reduces noise. Okay? That's made by Laird. And this starts working at 25 meg. All right, so at 2 meters, if you take a couple of loops through this, at 2 meters, you're gonna be, about almost 100 ohms of resistance. That's what you gotta use. Those little itty bitty ones that are about the size of my pinky, those don't start working until you get to about 450 meg, which means that if you're doing any 2 meter work, or any 70 centimeter for that matter, it's not big enough to do any damage, right? You gotta use big stuff to make this work. And I'll pass these around. I use this on transmission lines at AM sites to scrape off ground loops between the antenna and the transmitter. How do we know if we have a ground loop? If you touch the coax or the heliax and it's warm, you got a ground loop. So you put about 4 of these on that heliax and it scrapes off the ground loop and the heliax doesn't get warm. You can get this stuff easily from guys like DigiKey or Mauser. These are under a couple of bucks a whack. And these will actually do something in terms of taking RFI out of things. So here, I'll hand these guys around. You can take a look at them. And they're not horribly expensive, but the concept that you can take one of those little itty bitty clamp-on ferrites and scrape off any noise that you've got coming out of a booster that's beating your 2 meter receivers to death is, for lack of a better term, a fool's errand. This is the Laird piece, the big one. Not the really big one, but the big one. Maxwell's got a PDF of this, so you don't have to take notes. But you can get all the Laird stuff from DigiKey. The last time I checked on this part number, they had 6,000 of them in stock, and they were under $2 a whack. The PDF is on the website under syllabus, and you can download it now according to Mr. Maxwell. Anyway, that's what it looks like. They have 6,000 of them in stock. If you buy 10 of them, they're $1.39 a piece. I carry a bag full of these. When I'm out working on AM sites, and you should see what happens when you check this through TSA. They're like, when I do that, I always ask for Gentle Ben to do the strip search. But that's effective. And you know, if you're battling those kind of problems, you've got to get a big ferrite. This is a mixture 28 core material. You can look up the specs on this from the data sheet. It'll show you the curves in terms of what frequencies it really starts to work at. But bigger is better, and always a couple of turns through this. You know, if you've got enough length and your cable's small enough to get through it a couple of times, a couple of turns is really a good thing. RFI testing. Okay, don't burn the heretics. I ran VHF and UHF testing on a booster who will remain nameless. So this is our test setup. Noise floor, minus 86. That's at 146, 520. The span is 5 megahertz. That's with the booster on, running 12.5 amps at 149 watts. The noise floor has come up by 11 dB. That's the difference between a 10 watt radio and a 100 watt radio. Now it gets slightly better at lower power levels, but you'll notice that the noise floor has changed in terms of where it's noisy. Remember we talked earlier about boosters having RFI that kind of floats around based on loads? Well, this is one of the problems. So this is at, next time I'm going to get a bigger screen for my display. This is at 7.1 amps or 85 watts. All right. And you can see the spectra has changed again. Now it's building up towards the edges. And this is at 5 amps, which is 61 watts. The noise floor has increased 8.9 dB over the base noise floor of the test setup. And this is at 2 amps where it actually gets almost quiet. It's only an 8.2 dB increase in noise floor. And that's our baseline again, so you can see what our noise floor is after the tests. On UHF, things are better. That's because the harmonics always trail off, right? We all know that from basic RF. So that's the noise floor of the test setup. I don't know where this came from, but it just kind of was there for a second and gone. So we're at 108.6 with a base test setup. And that's the noise floor with at 12.9 amps or 149 watts output. The noise floor is increased by 8.7 dB. That's better than VHF, which was at 11. But still, that's a pretty sizable bump in the noise floor of your vehicle. And if that's getting into your receive antennas, right, you've just, your link budget for receive now has gone up by 8.9 dB. That's not inconsequential. 8.7. At 8 amps at 95 watts, the noise floor is up by 6.7 dB. And at 2 amps, it's 4.3 dB noise floor increase. So let's talk about how much transmit power you lose from 13.5 volts to 12.5 volts to 11.5 volts, right? Because what are we really concerned with about battery boosting is, you know, are we making all the horsepower we need to get the job done, right? And so I set up a test system for it. And the test system consists of my HP8920A, which has had a full cal back in 2019 from Amtronics, and that's NHTSA traceable. I used a Motorola XTL 2500 remote mount for both UHF and VHF. There's an Astron RS35 power supply there with its top off. The reason it's top off is so I can adjust the voltage output. The voltage output pot is underneath the circuit board. So you kind of got to reach in there carefully because you don't want to get across something that you don't want to get across. I used one of my Fluke 87.5 meters, and I have a Lynx Hall transducer amp meter. You can see the blue thing behind it. That's the amp meter, and then the Lynx is the readout on it. It's using a 5mA to 20 milliamp current loop. So let's look at this. So UHF, test frequency 446-100. For us in the EOSS world, that's one of our simplex frequencies. If I set the Astron to 11.5 volts, its output is 39.9 watts. It's a 40-watt radio. It's drawing 8.9 amps or 102.9 watts of power at 11.5. At 12.5 volts, it's at 42.6 watts, 8.3 amps, current goes down, right? It's 103.7 watts. At 13.508, this is what happens when you have 5-digit tools. You just push the high-res number, and you're like, I'm going to write it down. It's cool. All right. At 13.08, 508, that pot's relatively, doesn't have a lot of granularity, so you just kind of got to, you get it close, you're like, yeah, it's close enough. 13.8 is 44.1 watts, 7.9 amps, 106.7 watts. And even though Astron says it'll go to 15 volts, the most I could squeak out of it at wide open was 14.299. And I was lazy. I do have a Meanwell power supply that'll go to 16 volts, but I was just too lazy to throw it in there and set it up for 15 or for 14.5. So you're gonna have to live with the fact that I measured this at 14.299, which was wide open. And that was 44.2 watts at 7.6 amps or 108. Max voltage on the Astron. So what does that translate to? So I took the watts out and I converted them to dBm. Okay? So at 11.5 volts, we're at 46.01 dBm. 12.5, you're at 46.29. 13.5, you're at 46.44. 14.299, you're at 46.45. So from 11.5 volts to 14.299, there is a 0.44 dBm difference. It's effectively zero. An S unit's 6 dB. This thing isn't even going to wiggle a meter. You're not buying anything by boosting. It's not like you're doubling the output of the transmitter. It's not like you're going from 10 watts to 40. I don't see where there's a giant gain to be had here doing boosting.
I guess I had one question on that. You know, I know that the different, you know, it's from a power perspective, but some of the radios that, you know, want 12.6 or a little more with the microprocessors and some things in it, the radios start resetting at some point, or on some of the radios. So it's not just the output power, it's just some of the design of, you know, the radios. You didn't have that, you know, with the Motorola, but some of the HF radios and some different things is you'd be in the middle of QSO and the radio will do a power reset.
Well, Mark, those are really good questions. And frankly, I didn't test any amateur radios because I didn't happen to have any hanging around. And I picked the XTL 2500s because I got two of them sitting in my shop that are about to go into the excursion, bringing the total number of radios up to 8. Didn't we talk about loads? And if somebody really wants to explore at what point radios like lose their minds, love to. I've got that set up and I can run it. So, and it's pretty easy to do it. And if somebody wants to call me up and say, hey, let's get together and run a bunch of radios and see what goes away at what point, happy to do it.
I know Mark brings up a really good point there. Be very careful with some of the Chinese radios that are out there. They're very sensitive to power. And Mike's comment about you don't need to boost. Well, if you've got a Chinese radio, you might need to boost, because I've seen a few of those that freak out at below 12.5.
Well, that's really good information. But the other thing to think about, John, is if you buy the DX Engineering booster, I think it's about $300, right? So you know where I'm going with this, right? I mean, you can buy a nice, clean, used XTL 2500 for the cost of your cheap Baofeng and a booster, okay? So I'm just suggesting that fixing a $50 radio with a $300 booster might be a bit of a fool's errand.
The other thing that I've noticed is that even Japanese radios, the next step up, or top of the line in some cases, on some of the HF radios, they start splattering a lot if the voltage gets, not to 11.5, but at least lower 12 range.
Well, and again, if we want to do a whole, let's take a bunch of radios and test them, I'm up. And I've got this whole measurement thing down. I mean, I knocked this out in about an hour. And so now I know how to do it. We can do it again. And the HP 8920 will take anything from, AM up. So we could run it into it and look at it. And we can do things like look at the spectral output of the transmitters and see if it all goes sideways. I'd love to do that, but I need cooperation and a whole bunch of people to show up with radios to make that work. And yeah, I knew I was throwing a commercial pro radio at this project, and why? Because I had them available and it was fast. So let's look at a Motorola 50-watt VHF radio and just see what that looks like. Again, you're going to see here that between 11.5 volts and 14.299, there's not a whole bunch of difference here. The radio becomes really solid at 12 and doesn't change at all virtually above that. And it's down to 44.5 watts at 11.5. But again, we're not looking at a whole bunch of difference here. It's 0.96 dBm. It's under 1 dB from 11.5 to 14.299. Again, it's under a dB. It's effectively zero. But I would love to do that. And if there are people who would like to help and assist, I'm not willing to do that by myself. Come and see me afterwards, and maybe we can set up a pizza and test radio party somewhere, which would be a lot of fun. And I think we ought to line up a whole bunch of all kinds of radios test all that stuff, and at least have it available on the RMHAM website. So folks who are potentially looking at missions where, they're out doing some triathlon or something, and they're going to be running off a car battery, and they want to know what happens when, things go south. I will tell you that we had problems with these not liking particularly low voltages. And we run a booster in the truck to feed a bunch of these, and it's much happier. But we know what the spurious output on that booster is because we ran it through our test setup, and we've got it grounded, and these loads don't change. So it's not like, we're going from receive to transmit, and there's an 8 amp difference there, or 6 amp difference. And we've been able to tame that problem down to the point where it's not killing us. And just to give you a look at what the top of the truck looks like in terms of antennas, right? And now there's a XM radio antenna right there because it's cool. And but that gives you an idea of what's going on there. We have an LTE antenna. This Garmin brick has been with us since we built the truck. And I have to tell you, the only thing we've ever had to do to it was update its firmware for some weird fold-over GPS thingamabob, which was somewhat of a pain because you have to put it into Garmin mode to do the upload, and then you got to put it back into NEMA mode for us to use it. But we got through it. We have a DF system made by Doppler Systems out of Arizona in the back. We try to keep the back half of the truck RF quiet for the DF system, and then everything up in front. There's an SDR antenna that we use on the bricks, so the bricks can look at up to 6 APRS beacons simultaneously and digest all that stuff and do tracking. That's that antenna. We also have an ADSB aircraft ADSB receiver in the truck. There's a bunch of DMRs. There's a bunch of Wi-Fi. We have some FT8900s that we throw at APRS transmit at low power, okay, like 5 watts, okay? Anything more than that, and it tends to get into everything. Bunch of DMR stuff everywhere. That's the wheel and light bar that's eaten a couple of fuse holders already, which is fun. And I was out looking at the new Starlink phased array antenna, and because it's cool, and I end up in spots where I end up having to use satellite APRS, and I've gotten that to work. And that Jeff Deaton was instrumental in helping me set up the correct string to make that work. But there's only a small window when those are up in the aperture that you can actually make that work, but I've successfully done it.
What is the highest a transmitter that you're running that does not negatively affect your DF antennas? Is that why you were so low on APRS, or? Well,
first off, you only need...
Like you have your DMR antennas up there.
Yeah, and I'm running all that stuff at low power.
Low power.
Low power.
So like under 10 watts.
Well, whatever the lowest power level is on a 5550E.
Yeah, but you're not affecting your DF antennas.
No, because remember, we're DFing in VHF.
Yeah, but
okay?
roughly under 50 watt or 10 watts, you're not bothering it.
It's not bothering it.
But if you were to go to 50 watts, you would probably potentially blow the preamps in that DF.
Well, we've blown the preamp on the AOR radio in here twice. Okay?
But you're okay at 10 watts.
Yeah, we haven't blown it up. Now,
that's what I was wondering.
And I've cheated. I put a 3 dB pad in front of the AOR receiver.
Okay.
So I've taken 3 dB off my lowest level that I can DF
so your
at.
50's down to 25, which is good.
Well, and the other part of this is, so we're running the DMR repeater in here. Why? Because, I don't know, we woke up one day and thought it was a really good idea. And it's amazing to drive down the road and know that you always have DMR coverage as long as you got cell service.
You're never out of the range of the
You're
repeater.
never out of the range of the repeater. And I mean, it's just so weird because, you know, and now I've got the EOSS team that's got DMR radios. Their roam groups all have the truck here, and the ground station's got another DMR repeater in it.
Yeah. You know, they make hotspots for that, Mike.
No. But Doug, it's more fun to run a repeater.
I agree with you.
And we had them. We had the repeaters and the duplexers were left over. In 2017, we had the eclipse that ran through Wyoming, right? And so Edge of Space was tasked by NASA to fly a couple of payloads for NASA. And they wanted us to be at 80,000 feet at totality. And their cameras weren't looking up. Their cameras were looking down. And the reason was they wanted to see if clouds formed during the totality. And so we're out in the middle of nowhere, Wyoming. And of course, we're insane. So we built a 3-site microwave-linked DMR system that covered 7,000 square miles of Wyoming and installed it just to do the tracking and recovery. Because there were no other repeaters. There was nothing out there. And the system worked so well, we were out in the middle of nowhere. The sheriff's department was out with us. The sheriff's department on their P25 110-watt radio couldn't call dispatch. Well, we had a ham who was running the 911 dispatch center. So I handed the deputy my 7550, and he looked at me like I had 3 heads. And I said, try it, it's gonna work. So he calls dispatch. Craig Murphy says, yeah, I'm right here. And he's like, but we had better sites than they did.
One of the other things, right, recommend. Yeah, just wanted to mention with the antennas on the roof, right? One of the reasons you're using quarter wave dipole, quarter wave antennas instead of dual band antennas and things like that, which presumably would be additional gain, but the isolation, right, the rejection
Well, yes.
on your direction finding stuff, the rejection at 70 centimeters
is huge.
Is huge, right?
It's
yeah,
huge.
Exactly.
Right, so if we put dual band antennas on it, we'd blow up the DF system every single time, right? And that was the reason we did quarter waves back here. And we've measured this isolation between the DMR. Of course, I have no life. So one day I went out there and I swept every single antenna on the roof to every single other antenna on the roof, right? At both 70 centimeters and 2 meters. So I got a whole list of what those isolation looks like. And by using quarter waves here, we gained about, I want to say 10 or 15, maybe even 20 dB of isolation because they are detuned for the 70 centimeter band. Thank you, that was it. Yeah, forgot to mention that. Dave.
Before we move on, there's 2 questions from the chat.
Sure.
We're going back to voltage boosters and the sensitivity of radios to the supply voltage. Richard, KJ5CQX, says, I've also seen entry-level HF radios that will work at 12 volts, but tend to throw out third harmonics at increased level at 13.8.
Or the other way around.
Yeah. And of course, you're focusing on Motorola's with most of your testing. So, at the Chinese radios, as John points out, are a little more questionable.
Well, that's a great, I was never thinking about it the other way.
And I had asked you a question earlier today about DC to DC converters, where you're taking this, basically variable voltage input, and you want to get a fixed output out of it. And that might be a great application where you want to make sure a radio always gets 12 volts no matter what the power system in the vehicle is doing. Sort of the reverse of the problem that you're looking at.
Right, and that's exactly what we did to power the bricks. So I'm feeding the bricks 12 volts even, and it doesn't kind of matter what's going into them. And I think one of the reasons we ran into a problem with the bricks is we put SSDs in ours. And those had a different current profile and they changed things. But Yeah, that I never considered the fact that if you ran them at 13.5 or above, that they're generating more harmonic distortion. That was a great comment from the chat. What's next?
And Scott, K0WAV in Northwest Arkansas is asking the question, most rigs state 13.8 plus or minus 15%. So the low side of that range is 11.73. What is the effect on the rig at the low end?
Well, I think that would be dependent upon
The rig.
the rig. And again, let's see a show of hands. Who's interested in exploring that and would like to volunteer, and I'll buy the pizzas? Okay, great. Deal, right? So it looks like we might have enough people here to get enough rigs involved. And could you?
And Scott, if you'll let us know what kind of rig you're thinking of there in that case, that would make a good test subject.
And also the gentleman in front of him who said if we run them at 13.5, do we?
Yeah, Richard, if you'd let us know what the rig is that you saw the reciprocal problem. By the way, Scott has a follow-up question, which is the high side of that range then is 15.87, and what effects would you expect in that case?
Again, I think it's rig dependent.
About the same thing.
And I think if we're going to do this testing, I'll bring out the 50 amp mean well switcher that I've got that's reasonably well tamed. That's a 15 volt switcher, and you can dial it down, but it wouldn't go down to 11.5, which is why I didn't use it on this project, but it'll certainly go to almost 20. So now I want to switch gears a little bit now that we've certainly beaten the booster thing around a little bit. I want to talk about understanding vehicle loads. And I started off my presentation this morning saying, our vehicle got bigger and bigger and bigger, and the loads quadrupled. And as I mentioned, I'm about to throw a couple of XTL 2500s in the truck, bringing our total radio count now to 8. And there's a bit of a backstory. I wanted some P25 capable radios, primarily for interop and the world comes to an end parties. Yeah, and speaking of world comes to an end party, we put an XTL 2500 in the EOSS ground station van. It's a 110 watt VHF radio in the van, and there's a brother label on the front of it that says to only be used in the event that you hear the 4 horsemen of the apocalypse coming. So let's talk about understanding vehicle loads, right? Our technical loads run 29.8 amps, and we've measured it. The Whelen light bar is strobed, and when I put that on the truck, it was at the 2nd generation of LED light bars, which were virtually invisible in daylight. And I really wanted some punch because I spend, 2 or 3 hours on the side of some dirt road in nowhere, Colorado, and I want to make sure that somebody driving a truck who's been driving for 16 hours straight doesn't happen to clobber us with it. The Whelen light bar draws 40 amps. And I put a set of hideaway strobes in the rear taillights, and those add another 10 amps to that Magilla, which is 50 now. And if we're running the AC wide open because it's hot out, that's about 30 amps. Headlights and sundry loads, remember SLI, starting, lighting, ignition? Those run about 40. So in its current configuration, we're running just a smidge short of 100.5 amps. There's our there's our repeater in the back of the truck with the Magic MikroTik router board. This is before we plugged a bunch of other stuff in this thing. So the MikroTik's starting to get full. But that's the current measurement for the technical loads at 29.8 amps using our Fluke current monitor. So as I mentioned, our total loads are 149.8 amps. The Ford Excursion stock alternator shows up at 130. Now, Remember what we talked about earlier? So what do we think the Ford Excursion alternator is doing at idle? Half of that. So minus a little. So I got a 150 amp load and I got a 65 amp alternator. So that difference is going to be made up by the battery, okay? Which means that if I do that for any great length of time, Mr. Battery and I are going to have a parting of ways, at which point things are going to get real unhappy. I found a guy in Detroit, and I had him build me a 250 amp custom alternator with an external rectifier pack. Remember we talked about rectifier and heat? So the rectifier is a three-phase AC comes out of the alternator into a box about this big with a giant fan on it, and the rectifier is in it. And that provides a significantly better cooling than the alternator would get. Now, here's the other problem. The alternator on this thing sits right in the valley of the V10. So it's effectively the hottest point in the engine, and there's very little cooling up there. And that's not good. And as you can see, that's a giant case G6 alternator. The one that comes with the Ford's about that thick. And this is a lot bigger. And there's a whole bunch of wire here. That loom that's going that way, it's got the three-phase stator winding output, and the box is over to the left. And here's the truck out in the middle of nowhere, Utah. We were talking about putting the new Starlink flat mobile antenna on it, which uses phase array to talk to Starlink. Which I like that idea, except the problem is I go out to places like this because my phone doesn't work. And the minute you go to Starlink, my IP phone would work. So I kind of like the concept that it's going to be an hour and a half till I get to somewhere with cell phone service. On the other hand, I'm 67, and it's an hour and a half till I get to somewhere where there's cell service. So, you know, yeah, right. Listen, I got a shovel. It's this tall. Okay, we're good. But the point is, you know, we're out in the middle of nowhere. I don't know if I want to be found. Knowing what I know now after spending 10 years with the truck and dealing with all of the foibles of the power system, I think if I did it again, there's a guy in Milwaukee that builds second alternator brackets for V10 Tritons. And I think if I had to do it all over again, I'd put a separate alternator in and a separate battery and just call it tech loads. And I'd get all that stuff off from the SLI system. And I think I'd leave the strobes and all that craziness on it, but I would certainly take all the stuff that requires nice, clean, quiet power and throw it on its own alternator and battery. For a while there, we were having some fever dreams about throwing some more batteries in the back of the truck and using a hell-roaring isolator for it. The problem with doing this is you wake up in the morning and you go, it's not solving our problem of lack of generation, right? We don't have enough power coming out of the alternator to service all this stuff. All it's doing is allowing us the ability to not have a giant problem at idle. But at some point, I was going to put a pair of 100 amp hour Odyssey AGM batteries, which are, right, and strap them up. But we still get back to the limits of the alternator. And that's a problem. And if you want to see what one of those brackets look like, that's what it looks like. And it'll go into the Excursion. I haven't dive down that far in the rabbit hole yet, but I'm getting close. Tristan.
Sorry, this is a stupid question, but is it possible to retune the ECU or ramp up the idle speeds?
Well, that's a great question. And in fact, there is a way to jimmy the ECU and force it, instead of idling at, I want to say 800 RPM or so, you can high idle it at 1200. That would help, certainly. We thought about it, and the guy that made the how to jimmy it circuit wasn't convinced that it was going to work on the V10 ECM. He'd only done it on the 8s, the V8s. But that would certainly be a fix. The other advantage of running it at higher RPM is your air conditioning system is going to be happier. Mm-hmm. And, we've been out there at 90-degree days, and there's a lot of glass on the excursion. And you can have and that thing takes 64 ounces of R134. Ask me how I know, because we've serviced that air conditioner a couple of times.
But wouldn't you be concerned, I mean, if you idle it up and you're not getting airflow across the radiator, are you going to have to increase, the cooling in the radiator? I mean, there again, you get more heat.
Yeah, well, look, it's all, yeah, I mean, right? The other thing is that if we put another alternator in, we're going to load the engine. So, yeah, there's a whole bunch of, you open up the door and you have no idea what, hey, we fixed one problem, we've just made 3 more. No free lunch? There are no free lunches.
Yeah, I have no idea if my information's still current because it was about 20 years ago, but I know that the F-250 trucks had an option, an ambulance package, that you could order the truck with a second alternator already installed, plus a RPM device that would keep the engine speed up for running all the electronics that would normally be on an ambulance.
And so does Ford on their
I think it was
250
diesel.
series.
Yeah, it was the diesel engine.
Yeah, and diesels are another whole set of problems. And GMC for a while, you could order a 2-alternator engine, an engine with 2 alternators, and one was optimized for low speed, and one was optimized for high. And I remember seeing those. And that's a game you can play with alternators. I can put a smaller pulley here, which will increase the speed of the alternator at idle. The problem is that you'll saturate the alternator at highway speeds, so you get less power out of it. So we kind of played a little of those games with the one that we bought, and we had them downsize the pulley a bit to improve. I told them at idle I needed 150 amps out of the alternator. So we sacrificed some of the top end performance of the alternator to get 100.5 out of it at idle. Games you can play, certainly. The question is, how much brain damage and how big a check, right?
At what point are you going to start towing John's Whisper What generator behind you?
Well, so my partner in crime on the excursion is John Spainhour, N0 JPS, and he's like, why don't we just get one of those Honda generators and we'll put it on the hitch, right? We'll just run the generator. And there's a lot to be said for doing that, right? I mean, we've already lost our minds on this project. Why wouldn't we lose our minds a little more?
Well, I was going to suggest a brake on the accelerator. That'll work too.
Sorry? Yeah. Let's briefly talk about diagnosing problems with systems, right? Alternator wind on TX. Typically at idle, our setup, if I look really carefully with our Fluke scope meter, the noise out of the alternator is about 400 or so hertz, roughly in that range. 2 things. As your battery gets older with less capacity, its series resistance increases, the noise on the bus goes up. A quick sanity check on this is get a digital voltmeter, set it for AC, tag it across the terminals, right? It's going to scrape off the DC, and all it's going to show you is the junk. If that's greater than 100 millivolts, you got a problem. More than likely the battery's bad, okay? So that's just a quick and dirty way to do it. Battery testing, a company called MID-Tronics makes a patented battery tester that measures the series resistance in the battery. It's what General Motors makes their dealers buy to test batteries with. It's really accurate. You can find them used on eBay for, I don't know, $100 or $2. I don't have enough batteries to make that worthwhile investment. But that's the kind of the gold standard of hook it up, tell it how many cold cranking amps the battery's supposed to be. It's got 2 wires that go into each alligator clip that you put on the terminal posts, and it runs a patent pulse through the battery, and it looks at the echo coming out of the battery, and it from that determines if the battery's good or not and what its available capacity is. It's a really slick stuff. They've got a patent on it. It's got to be good because GM makes all their dealers buy it. Bad battery is probably the #1 reason you've got alternator whine. An alternator that's got a shorted field coil or a blown set of rectifiers will put a lot of alternator whine onto the bus. How do I know? My antique Porsche Bosch alternator, after 38 years, had a field coil short, and the sound system in the car had whine all over it. And the battery was okay because it had a recently good battery in it. And I went out and looked at it with my meter, and there was like half a volt of noise on the bus. And it's easy, you know, we had an archaeological dig to get at the alternator, and because the engine compartment is so small, you can't put your hands in it. The other thing is that Porsche ran a pipe from the front of the car, outside of the car, under the wheel well, to the back of the alternator to force air through the alternator to keep it cool. Remember we talked about alternator and heat? And the good news is you can order up those alternators from Porsche, even 38 years later. The bad news is it will make your wallet lighter. But you could get them. Well, that's half the battle, right? You know, I owned a 2012 Cadillac DTS. I needed the bun warming switch for the driver's side. I go down to the Cadillac dealer, like, we can't get them from GM. The car's only, at that day, was only 10 years old. Like, what do you mean I can't get a switch for this thing? Oh, we don't have them. I ended up getting one out of a boneyard. Okay. Bad wiring, loose grounds, corroded grounds. You see that stuff all the time in older vehicles. Look around. If there's rust under a ground lug, things are not going to be good, right? You want to take a Dremel tool. You want to polish that stuff off. Off you go. When we got the van, the USS van, we pulled all the Motorola NMO mounts off the roof, and we went up there. Jeff Deaton, N6BA, went up there with my Dremel tool with a wire brush on it, and wire brushed all those because they were all corroded up. So corrosion is not your friend in vehicles, and we all know that. Vehicles all get corrosion, right? So if you're hearing alternator whine, I'd be looking for bad battery first, bad alternator second, and wiring problems third. Dead battery, who's come out in the morning and put the key in and tried to start it, and it went, yeah, right. You know, there's a reason I usually carry a 150-foot long extension cord and a battery charger in the truck, right? The killer of batteries are parasitic loads. All modern cars have some level of parasitic load. So the way you find out is get a clamp current meter, turn the car off, put it on the negative lead, crank it up. It's probably half an amp. maybe a little more, maybe a little less. So if you leave your car out there and you got a 45 amp hour battery or something smaller, you guys can do the math as to how long you're going to be able to keep that car locked up and turned off before Mr. Battery shuffles off this mortal coil and leaves you calling AAA for a jump. Which is kind of why you always want to carry jumper cables. So our other problem with the truck is none of our radios are keyed. So you can leave the radios on and walk out of the truck. And radios tend to, the XTL 2500s in receive are about an amp. A bad battery, a bad or undersized alternator. So it's possible for you to stop and go traffic, heater running wide open, rear window defogger on, wiper blades going. In a modern car with an alternator that is a little bit undersized for the load because the manufacturer wants to cut corners, you can end up discharging the battery, coming home, locking the car up, come out 2 days later and it won't start because there wasn't enough charge left in the battery to get you over the hump.
Do you use any low battery cutoff safety devices in your truck?
We've got a Lind box that they make that senses whether or not we're above XY volts, which I can't remember off the top of my head, and it turns on a bunch of loads in the truck, but they're not the radios. And when it sees that goes away, in an hour it kills all those loads. But the radios aren't on that. So the answer is yes, and they work. Now when we're doing a mission, we bypass that auto off. Because if we're out chasing stuff around, I don't want something to go wrong on all the computers that would turn all the computers off. But if we did something stupid, I'd rather kill the battery and be able to complete the mission than have it turn itself off. RFI, if you're deaf, you got an RFI problem, right? If you're looking at the receive numbers on your radio and it's, running 20 over, odds are you got an RFI problem and you're not going to hear things. Again, my ferrite cores all come back? Oh yeah, they're sitting right there. Again, these things will help you out, but you got to, in order for you to fix the problem, you got to understand you got the problem, right? If people can hear you and you can't hear them, if the signal meter on your radio is showing 20 over, you're going to need to get to the bottom of that. And the easiest way to do that is unplug everything, right? Power the radio off from something else and start plugging things back in and see where the problem comes up from. And you got to look at everything. I was chasing a problem in my shack with 20 over noise on 20 meters. And so I went outside and I pulled the master disconnect, which is kind of a great way to see where the problem's coming from. The problem didn't go away. And then I realized that the reason the problem didn't go away was because I had a lot of IT loads on a UPS. The UPS took over, and the loads were still making the RFI. And I chased that down to a Belkin wall wart power supply that was leaking all kinds of grunge, and I beat it open with a hammer for two reasons: to make sure somebody didn't use it again, okay, and to figure out what was wrong. And of course, when they got their type acceptance, there was a piece of shielding on the inside of the plastic box that was there to keep the RFI from escaping. And when they put it into production, whoever the CM in some Asian country decided that saving a nickel per wall wart was going to be good, and they didn't put that in. And you see that problem all the time. Stuff gets its type acceptance and goes into serial production, and those extra caps and filters, man, those are expensive. Let's get rid of that stuff. We'll save money. Yes.
It's not just the wall warts.
Oh, it's everything.
Just the wall warts. We were doing some direction finding, and someone who happens to be in this room, not me, said, I can't hear the signal, there's S5 noise. And what it was, the Microtech router was emanating. So yeah, I believe we also took a hammer to that one. That's a very good resolution.
Well, in my,
Says he destroyed it. I guarantee you he destroyed it.
we were asked by a very large radio group to come out and look at a station they had that was sounding very poor, and in a top 10 market. And so I flew out to this place and I got in a rental car, and I dialed up the station. They were an AMer, and it was ugly, and everybody was very helpful. And we dug around and dug around and dug around and dug around, and found they had a couple of audio processors cascaded together doing about 40 dB of compression, hidden at the bottom of a rack underneath a whole pile of wire. And when we found those and got those out of the system, and things got a lot better. And because I didn't want to leave them around, I took them out in the parking lot and ran them over with my rental car and tossed them in the dumpster to make sure that, because if you leave that stuff around, somebody's going to grab it and they're going to use it again, and it's going to come around and bite you in the hindquarters. And so when you find stuff that's really, really, really ugly, you want to kill it, because it's like a vampire. You got to run the stake through the heart of the vampire, or it comes back around, and somebody will grab it for some reason, not understand that the skull and crossbones that you've drawn on it means something, and they'll use it.
Radio days, I worked at 1600 AM over at Hampton and Wadsworth. They've got a lake behind the building, and every time we found equipment like that, the word was, let's lake it. Well, there's a whole lot of broadcast equipment in the bottom of that lake.
Well, they were mortified that I ran out with those things under my arm, parked them under the wheels of the rental car, and backed them over them 3 or 4 times. But they did understand the reason we did that, which is those things, A, should never have been there in the first place, and B, if we left them there, somebody'd use them.
But Mike, the sad part is some broadcast engineer tried to recover it still.
There was nothing to recover. Those things were like this when I finished with them. If you're going to run a booster, the most important lesson here is ground the booster to the frame of the vehicle, and don't use 18-inch pieces of wire, okay? There's no good that comes from that. Some other things to look at for RFI: put ground straps between the hood and the chassis of the vehicle if they're not there already. The hinges on hoods and trunk lids are not particularly good, electrically speaking, and a short piece of braid between the bolt that holds the top of the hinge in and the bolt that holds the bottom of the hinge in is really good. Star washers, big star washers, right? Typical noise from this, tick, 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 as the high energy ignition system on the coil packs discharges. Those are good. If you're going to run HF, ask me how I know. The exhaust system. You're going to want to put ground straps on the exhaust systems on both ends of that. The exhaust system's all on big rubber bushings, right? The only place it's grounded is maybe the block of the engine. So a couple of short ground straps, really helpful. On my 02 Cadillac DTS, I did that so I could operate HF out of the car. And that was a lot of fun until one day, I was driving back from Vail, I was coming over Vail Pass, and there was an opening on 60, right, which is 5 meg. Okay, do you know what the CAN bus frequency is on a GM car? 5 meg. So I keyed up a 100-watt radio into a 102-inch whip through an SG tuner in the trunk, and the car lit up like a Madame LaRue pinball machine. Tilt, right? Tilt, right? Car's dead. Pull over to the side of the road, call my buddy at the Cadillac dealer. He just starts laughing, right? He goes, okay, you got to turn the car off and wait at least 3 minutes for everything to reset. Pull over to the side of the road, right? Get the car safely all over, right? And everybody who's driven Vail Pass knows there's two modes up there. Either slow, right, like 5 mile an hour truck, or 100, right? And I was doing the latter. And yeah, I finally get the car safely over to the side of the road, turn the thing off, wait 3 minutes, everything resets, car comes back up, CEL lights going, are you out of your mind? And yeah, I think the dealer charged me $60 to reset the CEL. That was before I got a CEL reset machine. But anyway, those are things to look for. If you can get AM radio outside of the metro area, you probably are okay. Questions? Did I put everybody to sleep here?
It's a party.
When we have a quorum of people who are want to do that project. Jeff.
I'm just curious, have you put any thought into modern vehicles like hybrid or all electric vehicles? You know, how does that?
I think you got a huge problem there. You know, when EVs do not support AM radio, there's a reason for it, right? And I think the concern you've got there is a lot of those have DC to DC converters that get you to 12 volts for running the accessories, but their current may be way limited, right? You'd have to ask whoever your EV vendor is how much current you can suck out of that thing before it goes tilt. And the other thing is, you know, walk around, turn the squelch off on a radio and walk around the vehicle. And, you know, if it's all making all kinds of noise, well, you're gonna actually have to drive the vehicle. The problem is that at idle, they don't make any noise per se. It's really a problem of what happens when you run it. So out of the gate, if your car does not support AM radio, your EV doesn't support AM radio, odds are it's going to be really challenging to get that to work with amateur radio. And then the next question is going to be contact the manufacturer and find out where you can tap off the aux 12 volt and how much current you can run out of it before you blow the thing up. That might be put the Honda generator. Well, yes.
Mike, I was just wondering, have you done any experimentation or do you have any ideas on what I should look for if I want to work with a dual battery, dual alternator system?
Well, first off, dual battery systems are great for a couple of reasons. You got a lot more capacity, and I'm assuming you've got a dual battery system because it's diesel. No. Look, if I was going to do the excursion again, I'd put a second alternator into it. I'd run a standalone alternator, a standalone battery for it, and I'd run all the technical loads off from it. I think it's a great solution. I'm saying that as someone who hasn't done it, right? I'm just, here, that and $6 will get you a cappuccino at Starbucks. Beyond that, I got no idea. The thing you got to look at is you need to use an alternator that you can hit with just B+ when the engine's running, okay? So you can't use any of these advanced ECM, CAN bus talking alternators. You'll never get it to work. The new Ford alternators are all talking to the ECM. They're having a whole data conversation, so that's not going to be a likely suspect for you. But the older ones, you can pull the diagrams off the website, and they need B+ off the battery to light up the field coil, and then they need to know that the engine's running. Doug.
In my Jeep Grand Cherokee, which I don't know if this is significant, is a diesel, I find I have very low electrical noise, except on certain frequencies on VHF, one of which happens to be the output of the Longmont Amateur Radio Club repeater on 147.27. If I'm doing less than 14 miles an hour, I have a half scale like S5 Birdie, And as soon as I cross through 14, it goes away. I'm assuming that is not an electrical system problem. It's probably a module and that communication in the vehicle, but it's very frustrating. Have you ever come across things like that? And do you agree that it's probably not the alternator electrical system?
It doesn't sound like it. I would, well, the only other thing to look at, Doug, is look at the bus voltage when that changes.
I believe it's fairly constant, but I will do that. That's a good,
I mean, I would,
that's a good point.
you know, for all I know, the ECM is like telling the alternator to do something.
Yeah, that could be, and I can put a voltmeter in there. And
I mean, if you see it
and
jump
watch
by,
it.
you know, 3/4 of a volt at that transition, you know where to start looking.
Yeah, that's a good point.
And the other thing is take Dirk for a ride, get a spectrum analyzer, and start looking around as you hit that.
I've been putting up with this for 140,000 miles. I don't know how many, well, if it was your vehicle, you would have it another 100,000. You're very good at maintaining and keeping them going, but I'm probably going to get rid of the vehicle and look for a cleaner one in the future. But yeah, that's a good point. But there's a lot of places you can get noise. And since this was a vehicular electrical, I did come across in my professional work as a two-way radio engineer. We had a particular radio that was not working well. It was a trunk-mounted radio with a control head on the dash. And there was obviously a ground loop or a ground problem, because the way the technician got it to work is he put his voltmeter across and started measuring, and it completed a circuit. So he left the voltmeter in it and said, "It's fixed."
So,
And that person said they had experience with trunked radios because the radio was mounted in the trunk. I'm not making this up. I'm not making this up.
so I'll tell you the quick VHF automotive story. For a number of years, I worked for ABC Sports, and I did a bunch of Indy 500s. And the RF crew was always running UHF. And I was like, why are you guys doing that? You know, this would appear to be a perfect environment for VHF. And they said, well, the problem you've got is at the high energy ignition systems in the vehicles, the RFI all loads up in the VHF band. So flash forward a number of years, and I joined the Porsche Club, and one of the guys from the Porsche Club grabbed me and said, do you know anything about radios? And I said, well, yeah, something. And they're like, we just built our own racetrack, and our problem is that the radio system works fine until we put cars on the track, and then the radio system doesn't work. And so I went out to the track, and it's a 2.8 mile road course with 150 foot of elevation changes and 15 turns. And the problem was they were running VHF. And so my brain, which can't remember what I had for breakfast, right, spooled back to, well, this is an Indy 500 problem, right? So the way to fix that was, or to prove that, was I got a bunch of Porsche Club members to come out, drive their cars out, and park one in front of every one of the bunkers, of the 15 bunkers. And then we put corner workers in all the bunkers, and we fired the radio system up, right? And the radio system worked perfectly. Then we went out and started the cars. We just left them at idle, and the radio system was completely off the air, okay? And that was with stock cars. That wasn't with race cars with, you know, 250,000 volt ignition systems. The point is that, you know, you got to pick your battles here, right? In a modern car, is VHF going to be a usable solution? May not, okay? Well, you know, I was in Portland 4 weeks ago. I got pulled over. I wasn't driving a Subaru. Come on, that was funny. But, you know, you got to pick your battles. And with modern cars, with all the high output coil pack, ultra high pressure fuel injection, you know, direct injections running what, I don't know, 15,000 PSI now. You know, all that stuff's potentially making a whole bunch of RFI that may not coexist well with VHF. I personally like running VHF in vehicles. Why? I got a big ground plane. It's got great reach. It's the end of the earth. 4 Horsemen of the Apocalypse band. Problem is, your car may not like it, and it may not be worth the brain damage to try to get it fixed. And running HF in vehicles, in this day and age with all the junk that's in the vehicles and the fact that GM uses a 5 meg bus, could be a bit of a problem. You're in stereo if you get 2 of them.
Well, yeah. This isn't directly dealing with power, but I have a vehicle that eats dashboard lights and buttons, the button lights. It doesn't, they don't last very long. I've been tempted to replace them with LEDs, but I've heard a lot of horror stories about RFI from the LED substitutions of lights.
Listen, there's a whole big giant problem with LEDs and CFLs creating all kinds of RFI, right? And so, I would buy one of those and I'd fire it up and I'd get a radio and I'd open the squelch up and I'd turn the gain up and see if when you turn it on or off, if it makes a noise floor. When we ran the booster tests here, an 11 dB jump in noise floor is almost 2 S units. You're going to know it, okay? That 8 dB at UHF, that's a little bit more than an S unit. You'll hear it. I would highly recommend it. Don't run HF in your vehicle. Okay? It's a fool's errand. I did it for years. After I got myself pulled off the side of the road on I-70 going through the Vail Pass, I was like, I'm not doing this again.
Thank you.
Any other questions? Dave, do we have any folks in the chat room with questions?
We do.
Perfect.
Let me first follow up with the radio information that the 2 attendees provided. One of them was an FTM 400 and an FT 857D. That was Scott. So let's see, he was...
Did somebody write that down?
He's got a picture of it.
I have a picture. I can email it to you.
Okay.
They say, he was asking about the effects on the radio from the low end to the high end of the specified range. The other radio, and he was the one, he actually had maybe a little dyslexia. It was harmonics at the low voltage, not at the high voltage. And that was an IC 7300. So it's certainly easy to find one of those around here to use for testing, and would be interesting to look at. Let's see, Jim Langstead asks, when you said 149 amp load, is that peak or continuous?
It was measured peak. I'd have to look at the average load. I was more concerned about peak, but that's a really good question, Jim. Thanks, Jim. Good question.
And wouldn't the battery provide some filtering on that?
Yeah, but the question is, correct, it would. So we could make up some of the deficit off from the battery. The question is, how long do we want to do that for? And I tend to want to, I want to fix those things forever. It's kind of like, going duck hunting with a bazooka. Let's just get it done and over with. And I don't have to look at it again because, when we're doing a track and recovery, there's 3 or 4 or 5 radios all talking at once. I'm trying to talk to Jeff, the ground station. We're trying to understand where the balloons are going. We've got a whole bunch of trackers we're trying to keep track of. I have a driver usually, and then I just operate the comms and the radio. And if I've got somebody in the back seat, I'll have them handle a couple of radios. It can get the workload in the truck can be really high, and I'm not. I don't really want to worry about the electrical system when we're in the middle of that. But that's a really good point. Yeah, the battery will make up for that at some point. We're going to have to put that energy back in. But great question.
Next one is from John AE7YH. Mikey asked if you have a build plan for your power system. And he'd be interested in buying the build plan. And maybe that could benefit RMHAM in some way financially.
Well, I would, we're about to redo the truck power, and we've got a plan for it, and I would certainly be willing to document that whole build plan and how we're going to do it. The problem, of course, is we built the truck, and then we poured a whole bunch of new gear into the truck, and we kind of just added it on. And now we're to the point where that's not happy anymore. And so everything with a capital E, everything except the antennas is all going to come out, and we're going to redo it from the ground up. And I'm really having evil thoughts about doing the second alternator with a set of Odyssey 100 amp hour AGM batteries in the back by where the loads are, right? So all I got to do is get the giant cable from the alternator back there and not a million of them. And we're really, really thinking about doing that.
That's all I have from the chat.
Any other questions?
Anybody else want to call into Car Talk?
Just had one last question for you. You mentioned that you put a repeater in the back of your truck, and I was wondering how you work that into the system without having additional problems, because I'm assuming you had to have 2 more antennas?
A single, and there's a duplexer into that system, and we're running it at as low a power as we can get the Motorola to go. Yeah, it's whatever the lowest power is. And does it cause some issues? Potentially, yes. We can potentially desense our simplex channels, 440, 6100. So we use 44650, 050 is the ground station simplex. Out in the field, we use 100, 150, 200, and 275. Yeah, whatever it is, right? For simplex ground communications for teams that are out in the field, grabbing stuff and coming back. If those guys are fringe, right, I'll turn the repeater off, because in our mission plan, the field personnel that are out in the field are the #1 priority for us. We need comms, we need to know they're safe, and we need to know what's going on. Me talking a couple of miles.
To go recover the balloon, right? So you
Yeah,
gotta maintain contact with them.
Ask Glenn.
So literally in the field, right? Literally.
Glenn shows up. So Glenn, we're out in the middle of nowhere, right? There's about 18 inches of snow on the ground. We got a payload that's 1.25 miles out, right? Glenn shows up with a handheld and a smartphone, and he's figured out where we are, right? Which he's become epic, right? He shows up, and I'm like, and I'm short of people, because we were like 3 balloons something or another, right? Or 4 balloon, and the TNR teams are all out trying to suck up payloads. And one of the problems on this is you got to get a landowner, right? You got to find out who the landowner is. You got to get landowner permission, right? And then we can get we can send a team out. So Glenn goes out there with a couple other folks, 1.25 mile walk in snow that's literally up to about his knees. And it was a balmy, like 28 or 30 degrees out there. And, my job, I killed the DMR repeater because I wanted to make sure that my simplex comms to the guys, I'm not line of sight, okay? They're over a ridge. Yeah, and on some of those where we go over the hill, we station hams at the halfway point that can see them, right? Because I don't have a visual. And Glenn's been on a couple of those where he was the halfway point, folks, right? From a mission safety standpoint, we have to know where our people are and if they're safe. And I'll happily drop the repeater, the DMR repeater, to make sure that all happens. And in those instances, I've got a 40-watt Motorola radio with a gain antenna on the roof that I'm running, making sure that I can talk to those people. And if they go over the ridge and it's not happy, I'm going to dispatch somebody to sit on that ridge and provide a relay point, or at least look at them. Because, you know, we don't want to have anybody out in the field get into trouble that we don't know, A, where they are, and B, what they're doing, and if they're in a jam. So the quick answer is yes. Does the repeater cause trouble? It can, and at that point, we pull the plug on it. But it's a lot of fun having your own repeater. Oh, a couple of watts. Yeah. Well, and then on the ground station's got another DMR repeater, and these are all linked into RMHAM, right? And I just want to thank the RMHAM management team for allowing us to do that. It's really great. And for our missions, having a DMR that works anywhere. And so, and the other thing is building roam lists, right? So if somebody drives up and they're on the roam list, they're going to my repeater. If they're at ground station, they're roamed over to the ground station repeater, right? They don't have to think about it. Pick up. That was the thing we learned when we did the Eclipse project. We built roams, right? The track and recovery team, who's never been to any of these places that we were in Wyoming and Nebraska ever, didn't have to know what repeater they were near or if it was going to work. They just picked up the microphone and transmitted. And the other thing about DMR is I'm standing next to the truck. The truck's running 40 watts, and I don't have any desense. There's no desense with DMR. It's all timed up, right? I mean, it's brilliant. And so for us, having access to the whole DMR system through RMHAM has been absolutely a revolution in terms of mission comms and being able to call Jeff, hey Jeff, you know, our computer's saying it's going to be the corner of X and Y. What's your computer say? Is that still valid? You know, we just got touchdown alert. So we have to tell the FAA we're flying. We have to give them real-time data. They route airline traffic around us. So we have to let them know we're on the ground, where this thing is, all of that data. We give it to them all in real time. We have an FAA Part 101 waiver that allows us to fly that stuff. And being able to hit the microphone into XGL, W9CN, DMR wide, you know, I need to know this. What have you got an update on predicts? Where are we at? Now, with our prediction system, has gotten so good. In the old days, before we had this, if I was within 10 miles of where something landed, I was like, that's a win, right? Now, I literally one day told somebody to drive down the road 1 mile, stop, open up the rear door on their car, and the payload was going to land in the back seat. And I was only off by 100 feet. Okay? But DMR, this stuff is really amazing tech. And thank you to the RMHAM management team for allowing us to go out and do that. And it's just, it's amazing. Oh, so the Chinese fly a balloon over. They shoot it down, right? So we've got a flight like 4 weeks later. So I'm calling down to NORAD, right, to find somebody to make sure that they understand we're flying stuff. Because the last thing I want to do is see an F-16 shoot down our payload and have 150 school kids sitting by the side of the road in tears that the government nuked their science project. And so I finally get a hold of somebody down there, which was you know, those people don't answer their phones. And I finally got a hold of somebody, and I was like, look, we're flying. And they're like, oh, look, you fly with the FAA. We got all your data. We aren't going to shoot you out of the sky. I was like, great. Hey, you guys want to come out and check out one of our flights? You know, call me. We'd love to have you come on out. But, yeah. Well, anybody have any other questions or comments at this point? Hey, thanks for everybody for coming out. Really appreciate it.
Thank you very much, Mike. Thank you, everybody, for attending, and we'll see you on April the 13th by Zoom for the 3D printing RMHAM University. Not here, by Zoom only.